Apex triggers are a powerful tool in the Salesforce platform. They allow developers to automate processes and enforce business logic. Triggers are pieces of code that execute before or after a specific database event. These events can be record creation, updates, deletions, or even database operations. Triggers are written in Apex, Salesforce's proprietary programming language. Apex is similar to Java and provides object-oriented features. This allows for complex logic and interactions with your Salesforce data. Mastering Apex triggers is essential for any Salesforce developer who wants to build robust and scalable applications. Triggers play a crucial role in extending Salesforce functionality. They provide a way to go beyond the standard features and customize the platform to meet specific business needs. Imagine you want to automatically update a related record whenever a specific field changes. Triggers can handle this seamlessly. For instance, if you need to send an email notification when a new opportunity is closed, you can use an Apex trigger. They are also useful for data validation, ensuring data integrity, and automating workflows that are not possible with standard Salesforce tools. Triggers are activated by specific events known as trigger events. These events dictate when the trigger code will execute. The most common trigger events are: before insert, triggered before a new record is inserted into the database. After insert, triggered after a new record is inserted into the database. Before update, triggered before an existing record is updated. After update, triggered after an existing record is updated. Before delete, triggered before an existing record is deleted. After delete, triggered after an existing record is deleted. Understanding these trigger events is fundamental to writing effective Apex triggers. Each event provides a different context for your code to execute and perform the desired actions. Let's consider a real-world scenario. Imagine you have a custom field on the account object called Industry. Whenever this field is updated, you want to automatically populate a related custom field on all associated contact records. This is a perfect use case for an Apex trigger. We'll use the after update trigger event to execute our code after the account record is updated. The trigger will then iterate through all related contact records and update the corresponding field with the new industry value from the account. Before diving into code, it's crucial to plan your trigger logic. Start by clearly defining the trigger's purpose. What event should trigger it? What actions should it perform? In our example, the trigger's purpose is to update the industry field on related contact records after the account's industry field is updated. Next, identify the objects involved. We're working with the account and contact objects. Determine the fields to access and modify. We need to access the industry field on both objects. Finally, outline the steps involved in the trigger's execution. With the logic planned, we can start writing the Apex trigger. Here's a basic example. Trigger account update trigger on account after update. For account AC trigger.new. List contacts to update = select ID industry __ C from contact where accounted = AC.ID. For contact contacts to update contacts to update. This code defines a trigger named account update trigger that executes after an account record is updated. It iterates through the updated accounts, checks for changes in the industry field, retrieves related contacts, updates their industry field, and saves the changes. Apex triggers provide access to valuable information about the trigger event through context variables. These context variables are crucial for understanding the specifics of the trigger's execution and the data involved. These variables offer insights into the trigger's execution context and the data being processed. By leveraging these variables, developers can create more efficient and effective trigger logic. Some commonly used context variables include trigger.new, a list of the new versions of the records that triggered the trigger. This is particularly useful when you need to access the new values of the records being inserted or updated. Trigger.old, a list of the old versions of the records that triggered the trigger, available for update and delete triggers. This allows you to compare the previous state of the records with the new state. Triggered old map, a map of the old versions of the records that triggered the trigger, with the record ID as the key, available for update and delete triggers. This is useful for quickly accessing the old records by their IDs. Trigger.new map, a map of the new versions of the records that triggered the trigger, with the record ID as the key. This allows for efficient access to the new records by their IDs. These context variables provide essential information for your trigger logic. They enable you to write more precise and effective code by giving you access to both the old and new states of the records. For instance, you can use trigger.new to access the updated values of fields and trigger.old to compare them with the previous values. This comparison is vital for implementing business logic that depends on changes in data. By understanding and utilizing these context variables, you can ensure that your triggers perform the necessary actions based on the specific changes in your Salesforce records. This knowledge is key to mastering Salesforce development and creating robust, reliable applications. Testing and debugging your trigger. Thorough testing is crucial after writing your Apex trigger. Salesforce provides a robust testing framework to ensure your code behaves as expected. Create test methods that cover different scenarios, including positive and negative test cases. Use assertions to verify expected outcomes. Debugging is equally important. Utilize the Salesforce debug logs to track the trigger's execution flow, variable values, and any errors encountered. The debug logs provide invaluable insights into how your code interacts with the platform and help identify and resolve issues effectively. Common trigger pitfalls and best practices. Writing efficient and maintainable Apex triggers involves understanding common pitfalls and best practices. Apex triggers are powerful tools in Salesforce, but they can also introduce significant challenges if not handled correctly. Here are some key points to keep in mind to ensure your triggers are optimized and error-free. Avoid SOQL queries inside loops. This is one of the most common mistakes developers make. Performing SOQL queries within loops can lead to governor limit errors, which can cause your code to fail unexpectedly. Instead, strive to bulkify your code by retrieving related records outside the loop. Use collections effectively to handle large datasets. Leverage Salesforce collections like lists, sets, and maps to store and process data efficiently within your trigger logic. Implement error handling to manage exceptions. Incorporate error handling mechanisms to gracefully manage unexpected situations and prevent data corruption. This ensures your triggers can handle various scenarios without breaking. Write modular code by breaking down complex trigger logic into smaller, reusable methods. This improves code readability and maintainability, making it easier for other developers to understand and modify your code. By adhering to these best practices, you can write robust, scalable, and maintainable Apex triggers that meet your specific business requirements. Following these guidelines will help you avoid common pitfalls and ensure your triggers perform optimally in a production environment. Beyond the basics, exploring advanced trigger concepts. In this chapter, we will delve deeper into the intricacies of Salesforce triggers, moving beyond the foundational knowledge to uncover more sophisticated techniques and strategies. Once you have a solid understanding of the fundamentals, you can start to explore more advanced trigger concepts that will enable you to create more efficient and powerful automations within your Salesforce environment. These advanced concepts are essential for developers looking to optimize their Salesforce implementations and ensure that their code is both scalable and maintainable. One of the key areas to focus on is trigger frameworks. These frameworks provide a structured approach to trigger development, allowing you to build more robust and flexible solutions. Explore trigger frameworks that provide a structured approach to trigger development, promoting code reusability and maintainability. By using a framework, you can ensure that your triggers are organized and easier to manage. This not only makes your code more reusable and maintainable, but also simplifies the process of debugging and updating your triggers as your business requirements evolve. Another important concept is asynchronous Apex. Learn how to utilize asynchronous Apex techniques like future methods and queuable Apex to offload long-running processes and improve performance. These techniques are crucial for handling operations that need to be processed in the background without impacting the user experience. Consider implementing trigger handlers to separate your trigger logic from the trigger itself. This separation of concerns makes your code cleaner and more modular, which is essential for larger and more complex projects. Further enhancing code organization and testability, trigger handlers allow you to isolate different parts of your logic, making it easier to test and maintain. Mastering these advanced concepts empowers you to tackle complex business challenges and build highly customized Salesforce solutions. By leveraging these techniques, you can ensure that your Salesforce environment is both powerful and efficient, capable of meeting the unique needs of your organization. Conclusion: Apex triggers are an indispensable tool for Salesforce developers. They allow you to automate business processes, enforce data integrity, and extend the platform's functionality. By understanding trigger events, context variables, and best practices, you can harness the power of Apex triggers to create robust and scalable Salesforce applications.